Hey everyone, and welcome to today's Explainer. We're going to break down the foundational terminology, the fascinating history, and the secret languages of the machines that basically run our entire modern world. Whether you're prepping for a big, highly competitive exam, or you honestly just want to truly grasp what's happening under the hood of your laptop, you are in the exact right place. So let's get started. Now here's something wild to kick things off. Did you know the word computer is actually an acronym? Seriously, most of us use these machines literally every single day. We just call it a computer, and we move on with our day without knowing its hidden secret. But that name itself holds a massive clue to exactly what this machine was originally designed to do. So here is our roadmap for today. First, we'll uncover the true meaning behind that acronym. Second, we'll look at the basic categories of computers. Third, we'll take a really fun time-traveling journey through the 5 computer generations. And finally, we'll crack the code on some absolutely essential computer abbreviations. Let's jump right into Section 1, the meaning of computer, and a look at the internal brain of the machine. Okay, so back to that acronym I just mentioned, computer actually stands for Common Operating Machine, purposely used for technological and educational research. It's pretty brilliant, right? The root of the word comes from the Latin computere, which simply means to compute. So at its most basic definition, it's just an electronic machine. It accepts data from you, the user, processes that data by crunching some calculations, and then generates your desired outcome. It's kind of like a giant puzzle. To process all that incoming data, the computer's brain actually splits the workload. That brain is essentially the arithmetic logical unit paired up with the control unit. The ALU is basically the math whiz. It handles all the heavy lifting, carrying out arithmetic operations like addition, subtraction, division, and multiplication. Meanwhile, the control unit is like the traffic director. It changes the order of operations in response to stored information, making sure everything flows smoothly. Together, they're what make computing possible. Moving right along to Section 2, categories of computers and how they process certain operations. So practically all computing operations out there fall into 3 foundational categories. First up, we have digital computers. These process information as distinct numbers or digits. This is what your laptop or your smartphone uses. Then we have analog computers, which process continuous physical data like temperature or pressure changes. Think of an old school thermometer or a traditional car speedometer. And finally, hybrid computers. These logically combine the sheer speed of analog with the memory and exact accuracy of digital. It's a really simple, elegant 3-part breakdown to keep in mind. All right, Section 3, the 5 computer generations. This is a rapid time-traveling journey through computing history. Take a look at this timeline. It provides a super fast, high-level overview of our journey. Notice how the major leaps in technology happen roughly every decade. We kick things off in 1946 with vacuum tubes. Then, boom, 1955 gives us transistors. 1964 brings IC chips. By 1978, we introduce VLSI. And from 1991 to the present day, we're living in the era of ULSI. The major theme you're going to see here is shrinking. The core components literally get smaller and smaller, allowing the computing power to get bigger and bigger. To put that into perspective, just look at the massive leaps in capability we made over just 3 decades. We went from enormous digital computers in the 1940s, like the ENIAC, running on hot, super fragile vacuum tubes, to a completely new paradigm. By the second generation in the mid-50s, we swapped those bulky tubes for transistors and began using magnetic disks for memory. But the true game changer? That arrived in the 3rd generation. Spanning 1964 to 1977, the industry moved to integrated circuit, or IC chips. A single IC chip could contain many transistors, registers, and capacitors all at once. This drastically reduced the size of the machine while totally skyrocketing processing speed. And that shrinking technology gave birth to something absolutely revolutionary: personal computing. In the 4th generation, we utilized VLSI, very large-scale integration. Because a single chip now had over 1,000 components embedded right into it, machines like the IBM PC and the Apple Macintosh could actually be manufactured for everyday individuals to have in their own homes. That incredible momentum pushes us right into the 5th generation, from 1991 to the present. We're now in the age of ULSI, ultra-large-scale integration chips, an era defined by staggering power that enables complex new frontiers like artificial intelligence and machine learning. Okay, on to our final stop, Section 4, cracking computer abbreviations. Let's translate some of the secret language of tech. We absolutely have to speak the language, right? Starting with the brains and memory. You've got the CPU, which is your central processing unit, the literal core of the machine. For memory, we have ROM, which is read-only memory, and RAM, random access memory. Then, moving to the physical media, you might remember using to load up software or watch movies. CD stands for compact disc, and DVD is digital versatile disc. Oh, and for those older deep-backed monitors taking up half your desk, CRT stands for cathode ray tube. Next up, let's decode the language of the internet. Every single time you browse the web, you're using a URL, a uniform resource locator. You're connecting via HTTP, the Hypertext Transfer Protocol. But notice the vital difference when you add an S. HTTPS means Hypertext Transfer Protocol Secure. That means it's actively protecting your data. We also have network foundations like TCP, Transmission Control Protocol, and IP, Internet Protocol. And if you ever need to troubleshoot a local network, you might actually encounter APIPA, which is a bit of a mouthful, Automatic Private Internet Protocol Addressing. Now here is one that blew my mind. Did you know virus is actually an abbreviation? No way, right? It stands for Vital Information Resource Under Siege. Honestly, what a dramatically accurate name. Below that, we have the everyday hero that connects all of our peripherals, the USB, or Universal Serial Bus. For power management, you have SMPS, the switched mode power supply, and the crucial backup, UPS, uninterruptible power supply. Finally, for specialized software used by architects and geographers, CAD is computer-aided design, and GIS is your geographical information system. Well, we've covered a ton of ground today, from the dual-brained ALU and CU systems right through the timeline of massive vacuum tubes shrinking down into modern ultra-large-scale chips, all the way to the specific acronyms that govern our hardware. But to wrap up our explainer, I want to leave you with a provocative thought as you continue to study. With artificial intelligence and machine learning completely driving our current 5th generation forward at lightning speed, what in the world do you think the 6th generation is going to look like? It's definitely something to think about. Thank you so much for joining me to demystify computers today, and I'll catch you in the next explainer.